because it has a greater net present worth. All right. Again, if you couldn't figure out how can you break the cash flow diagram to the standard form of the payment, you always can move the payments to the present time by considering each payment or receipt of the money as a single payment. All right. The last topic that we covered in this chapter is bond pricing. Bond is an investment option or investment instrument that you can choose to invest your money. Let's see how does it work. So it's kind of investment option like stocks or mutual funds. So when you go to the bank, you can get loans from the bank. In the bond, it's gonna be vice versa. The government, city, or any company that are gonna get loan from you, and in return they are gonna pay you back at the end of period of this bond. So there are some terms that we need to define when we are studying the bonds. So the first thing is life of the bond. When the city is issuing the bond, it says the life of the bond is 10 years. So if you buy the bond today, 10 years later, 10 years is gonna be the life of the bond, for example, for that bond, or 5 years, or 15 years, or 20 years. So life of the bond. Face value. The city said if you buy the bond today, 10 years from now, we will pay you $1,000 or $2,000 or $50,000. So we call this face value. The money that you will get at the end of life of the bond. So we call this face value. Price of the bond, the money that you pay to buy the bond. So the seller says the price for this bond is $20,000 or $500. So depending on the bond, they can set the price for the bond, and you pay for this if you want to choose this option for investment. Coupon interest rate. Suppose the face value is 1,000. Suppose life of the bond for this example is 5 years, and face value is $1,000. The seller or the government or the city or the company which they have issued the bond, they set the coupon interest rate. They say we pay you 5% per year on face value. So what you will get after 5 years is $1,000, the face value. Also, you get paid 5% And this face value over the first 5 years. So 5% times 1,000, it's gonna be $50. So $50 you get paid every year over the life of the bond. So this is how the bond is working. So you pay price of the bond over the life of the bond, which is 5 years, 10 years. You get paid interest on the face value, and at the end of life of the bond, you get paid the face value as well. So these are the important things about the bond. The seller set the life of the bond. The seller set the face value, and the seller set the coupon interest rate. This interest rate can be different than the interest rate that you will find in the market, or it can be different than a minimum attractive rate of interest that you are looking for, because it has been set by the seller. It can be something different than the interest rate that you will find in the market. So this is the only tricky part when we want to study about the bonds. Any questions so far? If not, let's work on this class activity. There is a bond with a face value of $1,000, which pays 8% compounded semi-annually. So it's a simple one. Just find what would be the payments every 6 months. All right, any volunteer? What should be the payments every 6 months? $40. The good thing about the bond is it covers many topics that we covered so far. So the interest rate is 8%, which has been set by the seller, but it's compounded semi-annually. So means interest per 6 months is 8% dividing by 2, which is 4%. So the face value is $1,000. This is how the bond is working. $1,000 times 4%. The bond, you get paid $40 per 6 months. Any question on this? All right. Now let's work on this example. So the city has issued a bond with a life of 50 years. The interest rate is 8% compounded semi-annually. So you get paid every 6 months. So basically you get paid $40. So what should be the bond price if the market interest rate is 12.36? So we would like to find the price of the bond. So first of all, we need to draw the cash flow diagram. So we have 15 years, but since we get paid every 6 months, the periods of time should be 6 months. So this is 6 months, so 15 times 2 is going to be 30. So we have 13 periods of time. Every 6 months you get paid $40 for 30 periods of time. And at the end you get paid $1,000 extra as a face value. And upfront you will pay the price of the bond. The question is, what should be the price of the bond if I is 12.36% per year? Or I can say how much you are willing to pay if the interest rate is 12.36% in the market. So what you need to do, you need to find the present worth of these payments, this receipt of the money, at present time with this interest rate. And say, okay, this amount of the money, it's gonna worth this amount, so I'm not gonna pay more than that. So this is how you can find price of the bond. How much this receipt of the money is gonna worth at this interest rate. But here I have periods of time 6 months, but the interest rate that you are given is per year. So I effective is 1 plus I per 6 months power 2, because we have 2 periods of time per year, minus 1. So this is 12.36%. We are looking for I per 6 months. So it's gonna be 1 plus I per 6 months square equals to 1 plus 12.36% or 1.236. 1 plus I per 6 months is going to be a square root of 1.1236. Then if you calculate that, I per 6 months would be 6%. 6%. So this interest rate per year is gonna have equivalent or effective interest rate per 6 months of 6%. Now, what would be the present force of the payment? I have $40 as a uniform size of the payment. I'm looking for its present value. $40 multiplied by P over A. Interest rate is 6%. N is 30. Plus 1,000 times P over F. 6%. N is 30. Is $1,000. It's gonna be 724. So this payment, this receipt of the money is gonna worth 724. So if the city said the price $750, you are not gonna buy that because you know that it's gonna worth only 724. So you are not gonna pay anything more than $724. Any question on this? These are just different types of the problem. If we are talking about this bond, and we know that the bond was issued 5 years ago, and today we are gonna set the price for that. So 5 years is gone. So the bond's life was 15 years. 15 years minus 5, we have 10 years left. So 10 years means 20 periods of time or 26 months per year. So 30 is gonna change to 20. The rest is gonna be the same. $40, you know that at the end of the periods of at the end of life of the bond you get paid $1,000. But the price is gonna be different because the period of time has been changed. Now after 5 years is gone, the bond is gonna worth 770, almost $771. It's possible that you buy the bond at the middle of time, so at the middle of life of the bonds. So 5 years gone, you buy the bond for next 10 years. So this is how you can deal with the bonds. So the only thing which is different is the number of periods, which is This has been changed from 30 to 20. This is another example. Since I'm going to talk about the exam a little bit, you are given with two interest rates. The MARR, minimum attractive rate of return, for this buyer is 10%, but the market interest rate is 8%. When you want to do the calculation to find the present worth, if you are given with two interest rates, you are working on the MARR because you want to invest your money, you set your preference, and you would like to get at least 10%. Although the market's interest rate is 8%, so instead of 6%, instead of 8%, payable semi-annually, so you are using 10% and find the equivalent or effective interest rate per 6 months for 10%. Good? All right. Let's look at, I have the exam that we had for last year, just let's have a quick review on that. Last year we had 3 problems and 75 minutes. We are gonna start the exam at 9:10, not 9:20, so 10 minutes before submission. To have 1 full hour for the exam. So the exam is starting at 9:10. I'll send the email. This company manufactured video games for the PlayStation. So the variable cost is $20. And the fixed cost is 10,000. 875. So there is a correlation between the price of this product in the market and the quantity that it can sell. So Q, the quantity that they can sell, has this relation with the price that they sell. So the greater price they set, the less demands they have, so or the less products they can sell. So the more expensive, the less amount of demand. Q is the amounts that they can sell, P is the price. Now the question is find the break-even quantity for the first one. So break-even point, it's the point that total cost is equal to the total revenue. Total cost is fixed cost, 10,875, plus variable cost, 20 times Q, depending on the amount of demand. The total cost is going to be $20 times Q plus 10,875. Total revenue is the price that they set for the product times the Q. So total revenue, total cost equals to total revenue. Set these two equals to each other. 10,875 plus 20 times Q equals to P times Q Good? You can find P as a function of Q from this equation. 1000 minus Q is going to be equals to 4P, or P equals to 250 minus 0.25 times Q. Just replace P with that equation, 250 minus 0.25 Q times Q. So 10x75 plus 20Q equals to 250 Q minus 0.25 Q squared. It's a quadratic equation. It's going to be 0.25 Q squared if you move it to the other side. Negative 230 Q plus 10x75 equals to 0. You will find two Q. One is 50, the other is 875. So we have two break-even points. $870, not 75. $870. Part B. What is the company's maximum possible revenue? Just what would be the total revenue? P times Q. P times Q is 0.25, 250 minus 0.25 Q times Q. So if you want to maximize this, differentiate and set the derivative equal to 0, find the Q. So derivative of total revenue with respect to Q, set it equals to 0. I don't show the process. $500 units. If they product 500 units, they can get the maximum revenue. Part C, it's asking about what would be the profits of the company if they're maximizing their total revenue. So profit is total cost minus total revenue. Q is 500, total cost, find the total cost. At the Q equals to 500, total revenue, just plug in 500 to find the total revenue and subtract total revenue minus total cost. At this Q. And what is the company's maximum possible profit? Now, if they want to maximize their profit, you should differentiate profit with respect to Q and set it equal to 0. The answer for that is 460. So this problem, there is a retirement account that you can deposit the money for 25 years. The question is how much money you should deposit every quarter to get paid for 25 years, which is 100 quarters. If you deposit this amount, $2,000, and the account is paying you 4% compounded quarterly. 4% means 1% per quarter. So you can find the future value. I is 1% and it's 100. What is the effective interest rate? You have the future value, you have P, you can find the effective interest rate per year and draw the cash flow diagram for this problem. You have done this problem before. Time is up, so I will post this on Canvas. You can work on this. If you have any